This is a map of Australia. It's a land under or the land of spiders and snakes and stuff. It contains 17 of the world's most poisonous snakes. It's a place where voting is a mandate leading to fines up to $72 and was the nation that once tried to ban the word mate. Now that's one Australian threat. But today, we're not here at the giant island nation looking at that. Instead, we're gonna look at some fuzzy business with its coastline. Not just its coastline, but with many others. Well, sources say that it's 35,821 kilometers long, some 36,735 kilometers, and one source says it's 21 kilometers long. Oh wait, that must be my cat. And here this one. One says it's, drumroll please, 25,760 kilometers long. So, what happened to nearly 10,000 kilometers of running land near the beach? Well, this is the coastline paradox. To understand this, let's firstly look at amazing land, a hypothetical state which, as you saw, is nothing but a square. Now let's say from amazing land, Bob II was tasked with finding the perimeter of said amazing land. All he would be needing is an amazing block of wood that is some length long, or more precisely, just a measuring tape. As long as you don't have a piece of wood that overwhelms the empire, in which case, good job Bob, you're fine. Even in that case, you can very simply just break the scale and there you go, the results are pretty good. Life is amazing. Okay, now let's look at north, which is a part of a circle. Now stuff gets a bit complicated. We see that a simple mega ruler fails. Right now we can see that smaller stuff works better than the bigger ones. Actually, we still have a way to do this with the mega scale. Well, that's because it's a circle and we have known them for a very long time and have done a lot of stuff with them. A bit of maths and we have the radius. Then we multiply with some numbers and 2 pi and get our results. Our results are still an approximation, but they are not out of the roof. Okay, let's move up one more layer. Let's say our empire was made by an old mathematical king person and on a tomb or something the old king had written that there was a pattern, the empire, and it wasn't total gibberish. Well, this one would certainly be harder, but again, maths. So, what happens if we don't have that? Well, it would be hard, but you could eyeball it and find some pattern from a map or a satellite. But that assumes one thing, and this one thing puts it all off. This is a shape that many of you may have seen. This is known as a fractal. Now, let's say a person would trace out an outline of the shape and find its perimeter. That's pretty good. Now, this may look right, or at least close, but when you zoom in, it all goes away. The fractal is a shape that has an infinite perimeter, while still having a finite area. The real world may or may not be a fractal, but it does go on in very deep. We can see that even shapes that look like shapes are really bumpy with bumps inside the bumps. Inside, you get the picture. As you can see, different scales of different lengths give out varying results from huge bobwood sticks to even as small as atoms. Unlike the circle where the approximation may not be too bad, here in many cases it can be very extreme. After all, the difference between perfectly finding the length of a fractal and just doing it freehand is infinity.